Alright, logarithmic functions 2.2. So the first, we're going to find the answer to each logarithmic equation, okay? So remember, knowing that logarithms are inverses to exponentials, and knowing that we can take the logarithm and rewrite it as the inverse, we can do that. So we'd go log base 5. What power is going to equal 625? Okay, so if we're not sure, we can just start. 5 squared is 25. Right, 5 times 5. Times that by 5, that's 125. Times that by 5, that's where we get 625. So 1, 2, 3, 4. So our answer would be 4. Okay, if we look at number 4, be 9 to what power equals 81? Well, it's easy, it's 9 squared. So the logarithm base 9 of 81 is 2. 2 log base 3, so we'd have 3 to what power equals 243. Well, 3 times 3 times 3 is 27, times 3 is 81, times 3 again is 243. So 1, 2, 3, 4, 5. So log base 3 of 243 is 5. Okay, number 3, probably a little trickier. 5 to what power is 0.2? Okay, well, it would help to understand that 0.2 is, that would be 2 over 10, which would reduce to 1/5. So that's really 1/5, which then that's pretty easy to see, that's a -1. Okay, 5, we've got log, when there's no base, remember, that's like log base 10. So 10 to what power is 1,000,000? Remember, count the zeros, 1, 2, 3, 4, 5, 6, and there you go. And finally, log base x of x to the 7th, be x to what power equals x to the 7th? Obviously, that has to be 7. Okay? Alright, now let's take a look at some graph ones. So, 7, we've got this graph. And it says, what is the value of x when f of x is 0? Okay, so f of x would be the y value. So when the y is 0, the x is 1. B, what is the value of x when f of x is 1? So if we go up here to 1, our value is 2. And C, what is the value of f of x when x equals 2? F of x equals 1. What is the value of x when f of x equals 4? So if we go up to 4 here, that's what we want to try to get to. Now this graph isn't very helpful on that, is it? Because we don't go quite that high. But let's take a look. Let's make a table here. So when x is 1, then 2, we have 0 and 1. Well, if we think about the inverse here, what power to the 0 equals 1, and what base, when raised to the first, is going to equal 2? Well, our base would have to equal 2. So most likely our equation is log base 2 of x. So if we were to get our answer of 4, so we want this to equal 4. So log base 2 of x equals 4. What would x be? Well, that's 2 to the 4th would equal, and it's 16. And our equation, y equals log base 2 of x, or f of x, probably would be more appropriate, wouldn't it? Alright, 8's kind of the same idea. What is the value of x when f of x is 0? It's 1. What is the value of x when f of x is 1? Actually looks like it's more 3 to me. What is the value of f of x when x equals 9? Looks like it goes up to 2. Once again, what would f of x be for? We don't go far enough, so what's the equation and how can we use that to find I? So once again, make that table. So I've got 1, 2, 3, and well, we skipped some. So I've got 1, 3, 9. 9 is 2, so 1, 0. Once again, that 1 and 0 don't really help us because anything to the 0 power is 1. But what about this one? B to the first equals 3. What does B have to be? Or B squared equals 9. Pretty easy to see that our base is 3. So we have f of x equals log base 3 of x. Which, if it's equal to 4, would be 3 to the 4th equals x. So x would be 81. Alright, 9. It says use the graph in the table of values for the graph to write the equation of the graph. Explain which numbers in the table helped you the most. So, if we're thinking these are logs, so it's basically log base something of 1 is going to equal negative 2. Okay? So thinking about the inverse, right, we'd go b to the negative 2 equals 1. Okay, well, what would make that work? Maybe let's take a look at this one. We have b to the negative 1 would equal 3. Okay, or b to the 0 equals 9. Okay, that one's going to be key, because normal b to the 0 equals 1. So that means there's something else going on here, some sort of shifting. And if we look at this, notice that it looks like it's been shifted down, possibly to the right or to the left as well. Okay, so normally b to the 0 should equal 1. So we're going to have to add an 8 to this to get it to be 9. So then we need to subtract an 8 from each of these. So 1 minus 8 would give us negative 7. 3 minus 8 would give us negative 5. So we're going to have log base something, parentheses, x plus 8. Okay. So, or no, x minus 8, sorry. Because we've got to think backwards when it's in parentheses. So what would make this work? Okay. And that can be the very difficult part here. Because we're trying to figure out that base. And so if we think of these numbers, so this was negative 2. And then we've got 3 is negative 1. And 9 is that. So actually, there's two different ways we could think of this one too. Because if I'm going this, normally that point would go right here, because our asymptote is right here. So we actually went down 2, okay? Which in this case would mean that this would be 1 and at or 0 and at 3 1 and then 9 2. So that's going to have a log base 3. So this is what our equation would look like. Okay, kind of a tricky one to deal with. Okay. All right. So this one says negative 2. We have an error. That tells me that my asymptote is at negative 2. Normally my asymptote is at the y-axis. Okay. So I know that I've shifted to the left 2. Okay, but that one away from the asymptote, it's still crossing the x-axis, so that part is fine. Okay, so we've got log base something of x plus 2 equals f of x, most likely. So then we have 1, 1. So I jumped over 2, I went up 1 more, and then 7. Okay. But the way to think about it is kind of to base everything off of that. If this were the y-axis, this would be 1, 0, and this would be 3, 1, and then this would be 9, 2. We see that kind of same pattern that we saw up here, so it's going to be log base 3 again. Okay? Tricky problems, though. Have to think through that way. But there we go, guys.